So 3M, we are on day 2 of Unit 2, all this wonderful algebra. I'm assuming you're now experts with expanding and simplifying, which would include FOIL. But let's just do 2 to make sure it's back into our brains. I'm asked to expand. That means to multiply. And simplify would mean to collect like terms and put them all together in a nice, neat pile. So what I see for the first example is 2 binomials being multiplied. So the back of my brain is thinking FOIL to make sure that I do 4 multiplications. My first multiplication would be x times x, my firsts, and get x squared. You're probably seeing lots of patterns over and over again. My outside would be x and 7, the two that are furthest apart from each other. If you multiply x and 7, you would get 7x. Inside would be the 5 and the x, the two terms closest together. And when you multiply those two, you would get 5x. Lasts would be the terms at the back of each bracket, the 5 and the 7, and we would get 35. Collecting like terms would be the 7x and the 5x are both terms named x, and we can put those together in a pile. The other two things have different names. X squared is different than x's, is different than numbers. So we can't do anything with them, leave them be. 7x and 5x, I have 12x's all together. Done. And that has 3 terms. It's called a trinomial. The second one, 2 binomials, we want to multiply. We're going to use FOIL to help us remember and then collect like terms. The first would be the 2x multiplied by the 2x. I would get, think numbers separate from letters, 4x squared. Outside would be the 2x multiplied by 5. I would get 10x. Inside would be the negative 5 times the 2x, negative 10x. Interesting. The last would be the negative 5 times 5, negative 25. Interesting assortment of colors. Sorry about that. I now collect like terms. I have x squared terms, I have x terms, and I have number terms. I'm going to keep those piles separate. 4x squared. I have 2 piles of x's, 10 and negative 10. I have no x's left. Subtract 25. Interesting. Yesterday we also talked about factoring, which is to write something as a multiplication, which is basically going the opposite direction that we just did. So I have 2x cubed y plus 8xy squared, and I want to write that in factored form, which means I'm going to have a multiplication. So my goal is, if possible, find a greatest common factor, and then in brackets show what I would multiply it by to get the terms I started with. So for 2x cubed y plus 8xy squared, I'm going to separate my thinking with my numbers, my x's, and my y's. So what number goes into both 2 and 8? It would be a 2. What power of x goes into both x to the invisible 1 and x to the 3? Just an x, or x to the 1 goes into both of those. Y and y squared. The greatest common factor would be just y. It divides into both y to the invisible 1 and into y squared. Done that, I pause for a moment and think, what does 2xy multiplied by give me the first term, 2x cubed y? Well, I already have the 2 taken care of. I already have the y taken care of, but I don't have enough x. X to the invisible 1 times x to the what gives me x cubed. It would be x squared. My rule is keep the base, add the exponents. Now I'm thinking about my second term. 2xy times what gives me 8xy squared? I'm thinking about my number first of all. 2 times what gives me 8? 4. X times what gives me x? I don't need any more x's. Y times what gives me y squared? I need another y. I'm just going to write that in one color so it's not quite so confusing. 2xy times x squared plus 4y. If I use the distributive law quickly in my mind and just check, I should get what I started with. And that's called factoring. Today, we're going to do factoring of simple trinomials. So it's a little bit different thought process. If I'm asked to factor, I am asked to write as a multiplication. And my first thought is there a greatest common factor? So number one, think, is there a greatest common factor? So a number or variables that go into all of the terms. Looking at the first one, x squared plus 5x plus 6. I think about my numbers separately from my variables. There is not a number that goes into 1, 5, and 6 other than 1. And I'm looking at my variables, x squared, x, and nothing. There is no power of x that goes into all three of those terms. So there is no greatest common factor for that one. So now I have to think back to the FOIL that I've been doing the last 2 days and think, you know, if I had something that looked like that and did FOIL on it, my answer often looked like that. So that's our job today, is to come up with the 2 brackets that would give us x squared plus 5x plus 6 when we multiply. Well, I know at the beginning of both of those brackets, for my firsts, I need an x and an x. X times x is x squared. Check. And I'm going to skip the middle 2 for just a moment. I know I need 2 numbers here and here that are going to multiply to give me my last. Those 2 numbers would have to multiply to give me 6. So I'm thinking already, what are my possibilities? Well, what multiplies to 6? 1 times 6 or 2 times 3? That's the only possibilities. So the 2 numbers in the brackets would have to be 1 and 6 or 2 and 3. So then I think about outside, inside. And when I multiply the outside terms and the inside terms, I'm going to be able to simplify them and come up with 5x. So I know those 2 numbers must also add to 5. Of those 2 possibilities, everything being positive, which 2 would add to 5? Those 2. So my 2 numbers would be positive 2, positive 3. Do a quick check. If I did FOIL on those, I would get x squared plus 3x plus 2x plus 6. So I'm going to do a quick FOIL. First, outside, inside, last. We can put those together and get 5x. Bingo, I factored it correctly. Let's do this second one. X squared plus 2x, subtract 15. I am going to look at all 3 terms and think if there is a constant or a variable that divides into all 3 terms. There isn't a number that goes into all 3, and nope, there's not an x in all 3 terms. The last term does not have an x. So I don't have a greatest common factor, at least not that's more interesting than 1. So because this is a trinomial, I know that I can set up a set of brackets, and I'm thinking the opposite of FOIL. What goes at the beginning of both brackets that when I do my firsts, I get x squared? It's going to be x and x. And then my thinking is from FOIL, my lasts, the 2 numbers, would have to multiply to negative 15. If I were to do outside, inside, and simplify, those same terms should add to give me 2. So what 2 numbers multiply to negative 15 and add to 2? Well, my brain is starting with the multiplication. So what multiplies to 15? 1 times 15, 3 times 5. Only two choices. 1 and 15 will never get you to 2. It's got to be 3 and 5. One of them is going to be positive, one of them is going to be negative if I'm going to multiply to negative 15, but I want to add to positive 2. So the bigger one is going to be positive. So my two numbers will be 5 and negative 3. Do a quick check. Do those two numbers multiply to negative 15 and add to positive 2? Yes. Order doesn't matter in the brackets, so I'm going to go with positive 5 first and negative 3 second. You don't have to do a check on paper like I am, but I'm going to do FOIL real quick with my two blue brackets and make sure I get where I started. X times x for first is x squared. Outside would be x times negative 3. Inside would be 5 times x. Lasts would be negative 15. Yes, if I put those two together, I get what I started with. Example number 3 is x squared minus 3x plus 2. I see a simple trinomial that has no common factor other than 1. So I know that I'm going to need an x and an x to multiply to x squared. I know that I need two numbers that multiply to 2 and add to negative 3. Nicely, the only possibility to multiply to 2 is 1 and 2. And I know I want positive 2, so both of those would have to be positive, or both of them would have to be negative to end up with positive 2. If I want to add to negative 3, then my choice would be negative 1 and negative 2 factored. 3 more to factor, and these ones are kind of interesting. X squared minus 9. So my thought process is there a greatest common factor for those two terms? Not that's more interesting than 1, because there's only x's in the first term and only numbers in the second. So there's not a greatest common factor. But that doesn't also look like the trinomials that we were just doing. So I'm going to write it just a little bit differently for the first time. X squared plus 0x minus 9 is the same problem. I've just put a 0 in the middle there just to show you a little trick. This looks like the trinomials we were just doing, and that I know how to handle. Two sets of brackets, x at the beginning of both to give me my x squared. I want to multiply to negative 9, but add to 0, because I don't really want an x term in the middle there. Numbers that multiply to 9 would be 1 and 9, 3 and 3, and you know what? If I had 3 and negative 3, that would multiply to negative 9 and add to 0. So I see that if I have a 0 or invisible middle term, I can set up this nice set of brackets where one is positive, one is negative, but the numbers, the back half, are the same. And the letters at the front half are the same. So let's try one without writing that middle 0 term. This one is the same as the one before. It has a minus sign here, and it has something that I can write identically at the front of both brackets, namely 3m, 3m. And there's something that I could write identically at the back half of both brackets, 4n and 4n. And if one of them is positive and one of them is negative, then I won't have a middle term. This is called the difference of squares. And it's just a particularly pretty thing to factor. There's one more. I see two things that are nicely factorable with a negative sign in between, which means difference or subtract. So I know that I need the same thing at the front of both brackets, which would be 9 and x. One of them will be positive, one of them will be negative, and I need the identical thing at the back half of both brackets, which would be y. Okay, one more and see if we've got it. First one, 5x squared minus 10x subtract 40. I'm thinking number one, is there a greatest common factor? We should always do that first, and for this one there is. It would be the number 5. It goes into all three terms. What I'm left with when I factor out that 5 would be x squared. I'm thinking, what do I multiply that by to get what I started with? Subtract 2x. What do I multiply by to get negative 40? Would be negative 8. The second thing I would think about is, can I keep going? Is it a trinomial, like I did where I'm undoing FOIL, or is it a difference of squares? What I see in the brackets could be a nice trinomial, but it is not a difference of squares. So I'm going to try. With a trinomial, I know I want it to be like that, so I'm undoing FOIL. At the beginning of both brackets would be an x. I need two numbers that multiply to negative 8 and add to negative 2. My possibilities for 8 are 1 times 8 or 4 times 2, and you know what? 4 times 2 could get me to a 2. If one of them is positive and one of them is negative, and I want to add to negative 2, my negative will be the bigger one, and positive. So x subtract 4, x add 2. And that is fully factored. For the second one, I'm just going to go underneath it. For the second one, I'm considering, is there a greatest common factor for both of those terms? And there sure is. I'm going to think numbers first, A's, then B's, then C's. So for the numbers, a greatest common factor would be 3. For the A's, there's an A in each, so I could write A as the greatest common factor, part of the greatest common factor. There's a B in each, but there's a C in only one of them, so that would be my greatest common factor. I'm thinking, what do I multiply that by to get my two terms? For the first term, I've already taken care of the 3 and the A and the B. So what's missing for the first term is c squared. What do I multiply 3ab by to get the second term? Well, I need that subtract sign first of all. 3 times what gives me 27? That would be a 9. I already have the a, and I have a b. I want b cubed. So I'm going to have to multiply my greatest common factor by b squared to get a b cubed. So I have done the greatest common factor. I need to look in the brackets and see if I can do anything further. Is it a simple trinomial? No, there's only two terms. So it could be a difference of squares. Well, it is. There's a subtract sign, and I can write two brackets with identical terms in the front and the back. One will be positive and one will be negative for a difference of squares. In the first half of both brackets, I would need a letter C to multiply to c squared. At the back half of both brackets, I would need a 3 and b to end up with 9b squared. Now it is fully factored. Number 3, a cubed plus 10a squared plus 25a. Looking for a greatest common factor, first of all, I see that there's an a in all three terms. That will be my greatest common factor. A times what to get the first term? I need a squared, so that when I multiply by a, I get a cubed. I still need the number 10 for the second term, and I need an a, because a times 10a would be 10a squared. Plus, for the third term, I have my a, I need 25. So I've done my greatest common factor. Now I look and see if I can go any further. Write the a again. Looking in the brackets, I see a trinomial, 3 terms. So I know I'm going to factor it by writing it like that, and my thinking is like undoing FOIL. What goes at the beginning of both brackets would be an A. I need two numbers then in the back half of the brackets. Multiply to 25 and adds to 10. Well, for 25, it's 1 times 25 or 5 times 5. And it just happens that 5 and 5 would also add to 10. That is now fully factored. Last one. I look and see if there's a greatest common factor for both of those terms. There's 256 in the first term and no other number besides 1 in the second. There's no b's in the first term. So there is not a greatest common factor other than 1. So I'm going to think of my other two strategies. Is this a simple trinomial or a difference of squares? This is your hint. There's only two terms and a difference or subtract sign. This one is going to be a difference of squares. Two sets of brackets. One is positive, one is negative. I need two numbers at the front of those brackets that multiply to 256, and they have to be identical. 16 and 16. At the back half of the brackets, I need a term that's identical in both and multiplies to b to the 4. B squared and b squared. It looks like I'm done. However, if you're clever, you might notice that this one is also a difference of squares. So I could go a little bit further. We don't have a beautiful rule for an addition of squares, so I'm going to leave him alone. For 16 subtract b squared, I can write two sets of brackets where one is positive, one has a negative sign, and the terms are identical in the front and the back of both. I need 4 and 4. And at the back half of the brackets, I need b and b. Now it is fully factored.